In this lesson, we're going to be looking at variables again, but only this time, these variables are going to be containing lots of data instead of just a single number or a single piece of text. In other words, we're going to introduce you to collections. And by collections, we mean lists, arrays, data frames, and series. In the last lesson, we learned about how to store data inside variables, and we learned about data types. In machine learning and data science, we often need to work with, well, a lot of data. As such, it would be silly to put each piece of data inside a separate variable. The alternative to assigning a single value to a single variable like this is that we have a single variable that actually contains lots of data. And that variable will represent a collection. One of the most common types of collections that you'll encounter is the list. Lists are pre-built into Python and they're part of the language. Let me show you what a list looks like. I'm going to create a list called prime numbers and set it equal to a collection of 5 primes. And the way to do that is by using this square bracket syntax. I'm going to open a square bracket and then give my first value 3, then put in a comma, give my second value, say 7, another comma, third value 61, comma, 29, and 199. And just like that, we've created a variable called prime numbers that holds on to a collection of 5 values. Now, just out of curiosity, let's take a look at what the type of the prime numbers variable is. Type prime numbers, shift enter, and we see that it's a list. Now, one thing that I'll mention is that a list in Python, doesn't have to be numbers, right? A list can contain all sorts of data. For example, here's what a list of strings would look like. Cool people is equal to square brackets, single quote, Jay-Z, comma, single quote, Gandhi, comma, single quote, and me, single quotes. There we go. The important thing to note is how we substituted Jay-Z for Kevin Spacey in this list. In any case, a list is just a variable that holds on to a bunch of values. And it can even hold on to values of different types. Check this out. Primes and people is equal to square brackets, King Arthur, comma, 17, comma, 11, comma, single quote, Jennifer Lopez. Now, even though we've got 3 different lists, one with whole numbers, one with text, and one with a mix of different types of data, all of these 3 variables are actually of the same type. They're of type list. So now that we've covered the syntax for creating a list, I'm going to show you something even cooler than storing data in lists. And that's retrieving data from a list. So the question is, how do you pull out a particular value from one of these lists? Here's the secret. The way we grab a particular item from the list is by that item's index. What do I mean by index? The index is just the item's position in the list. Let me show you what I mean. If I type prime numbers and open the square brackets, between these 2 square brackets, I can put a number. And that number is the value of the index. So say I put in the number 2 and hit shift enter. I get back the value 61. But 61 is the 3rd item in this list. Why is it the 3rd item? Well, it turns out programmers really like to start counting from 0. In other words, that first item, number 3, is at position 0, 7 is at position 1, and 61 is at position 2. Now, oftentimes, what we're going to be doing is storing the value that we pull out from a list in another variable. So we can do something like this. Best prime ever is equal to prime numbers, open square brackets, 4. In this case, we're pulling out one of the numbers from the list and storing it in a variable called best prime ever. Now, I know you might have a different favorite prime number too, but I'm sorry to say, it's not going to be as good as 199. Let me give you another example of a list. Say we had a list of eggs or egg objects, and we want to pull out the egg at index 1. Which egg would we be pulling out? Which egg is my egg equal to? The answer is we would be grabbing the second egg in the list, the spotted one. Again, this is because programmers start counting from 0. Now, the reason I'm belaboring this point so much is because forgetting to count from 0 is super common, and these off by 1 errors will also crash your Python program. Check out what happens when we write prime numbers, square brackets, 5, and hit Shift Enter. We get an error that reads index out of range. And that's because we're trying to select an item beyond the length of the list. Our list has 5 items, and we're trying to select the item at position 0, 1, 2, 3, 4, 5. The item at position 5 is the 6th one on the list. Since there is no 6th item, our Python program goes down in flames. Index out of range. So if you ever see these cursed words in your crash logs, now you know why. Let's change that 5 back to a 4. Now, lists are pretty common in Python, and we'll be working with them a lot. However, we'll be encountering quite a few other kinds of collections too, and a lot of them are very, very similar to the list, but they are classified as a different data type because there are subtle differences. In scientific computing and machine learning, we're going to be working with another data structure very, very often, namely the array. An array is like the list's stepbrother. He's somewhat similar to his sister, but he's got a different dad. You see, the Python list is like a ballerina. She's flexible, friendly, versatile. She can grow and shrink in size, and she can hold on to different types of data, like numbers and text, in the same list. The array, on the other hand, is a weightlifter. He's strong, and he's very good at particular tasks, but he's less versatile. He's also so buff that if he tried to punch you, he couldn't reach around his own pecs. But that's beside the point. All the data in an array must be of the same type. So an array must be all numbers or all strings, for example. Now, believe it or not, you've actually already encountered an array. Remember how we were looking at the regression intercept when we were estimating the movie revenue? Below the cell, we saw the output array parentheses square brackets minus 7,236,000. In this output, you even see the word array, so we know that we're working with one. But let's make this more explicit. Let's check the type of regr.intercept underscore and hit Shift Enter. Now, if you see this error, just like I do, it's because I haven't actually run any of the Python code in the prior cells. So I'm going to go to cell, run all, and then my notebook will know about the regression intercept, so that now it will correctly evaluate this cell. And what we discover is that the full name of this data type is NumPy.ndArray. The cool thing is that working with arrays is actually very similar to working with lists. In other words, we can use that square bracket syntax. So if I write regr.intercept underscore square brackets 0, I'm pulling out the first and only value from our array. Hitting Shift Enter, I see this value printed below the cell. Up here, in contrast, I was looking at the entire array. But in this cell, I'm just looking at one of the values inside of this array. And I'm accessing this value with the square brackets notation and providing an index at value 0. Okay, so we learned about lists and arrays in Python. Both of them use the square bracket notation, and through both of them, we can access individual items using an index. The index is just the position of the item in the list starting from 0. And this brings me to a very, very important point. Namely, do you know why the programmer quit his job? It's because he didn't get a raise.